Welcome, everyone. And all of you are gathered here to learn about how Prime Video peaks for peak NFL streaming on AWS. And if you're here to learn about how it happens, how all the magic happens, let's start with how many of you watch Thursday Night Football every Thursday? Can I get a raise of hands? There's quite a few. And that's what we're going to talk about in this story out here in this session, of what strategies does Prime Video uses on AWS to be able to meet those demands. And to start off with, I'm Tulip Gupta. I'm a senior solution architect with AWS, been with AWS for the past 3 years, and I support the media and entertainment accounts under AWS, and primarily Prime Video. And today I have with me Elliot and Ralph, who are going to introduce themselves later on in the session. And together we're going to talk about the challenges, the solution, and how it kind of ties up together with our AWS well-architected framework. And so to start off with, we'll talk about the NFL Thursday Night Football on Prime Video. And to talk about the strategies, Elliot will talk about the multi-region, then Ralph will come over and talk about the elastic scaling, and we'll end with the well-architected framework. And so if you watch Thursday Night Football, most of you do, it seems, it gets really annoying if it doesn't buffer, right? And you're not able to watch it properly. And so for live streaming, it's really important that it's delivered at real time and at a good high quality. And Prime Video obviously expects those demands to peak at certain times of the day, and especially during those TNF games. And so that's what we are doing out here, is to cover with multi-region and elastic strategies. So before I kind of move on to the next slide, how many services do you think Prime Video uses on AWS? A quick raise of hands, whoever wants to answer. No one? Close enough. It's actually 120 plus. And we use big services like S3, EC2 to smaller services like SNS and SQS as well. And so that brings us to what was the business opportunity? Again, going back to those Thursday night games, you want to be able to cost-effectively scale and delight millions of subscribers around the world. And the numbers keep on increasing as Prime Video streams it every season, every year. And so the challenges are to scale out those infrastructure to meet those demands. How can we scale our EC2s? How can we scale our EKs? How can we scale every infrastructure on our AWS to be able to meet those demands? And obviously the solution was multi-region and auto-scaling. Before I kind of go into the solution strategies, some quick FAQs on Thursday Night Football. So on September 7, 2017, that was the first time the NFL game was co-exclusively streamed on Prime Video. And since then, we have just grown. In 2022, we exclusively streamed, and we saw an average of 10 million viewers. And in 2023, it jumped to 17 million. That's quite a bit of jump, right? And in 2024, season 3 average was 18% higher than 2023. And I'm not going to tell you the number because Ralph is going to quiz on you on that later. And in 2024 also, we saw the biggest NFL event in Prime Video history, the Giants versus Cowboys game, which was the most watched streamed NFL regular season game in history. It was an all-time high for TNF for Prime. And with that, I'll hand it over to Elliot to talk about the multi-region strategies.
Thanks, Tulip. Hey folks, let's get a quick pulse of the room. Raise your hand if you're an NFL fan. Okay. Also raise your hand if you've ever been an on-call engineer. Okay, about even population. So those two groups are my primary customer cohorts. Imagine you're getting set up in your lounge room, the football's about to start, maybe you've got your snacks, you've got your mates over, and you hit play, and you're presented with a spinner, and it just sits there and spins, and nothing's working. It'd be pretty disappointing, right? Pretty devastating experience. Also imagine if you're an on-call engineer at that point in time, and you get paged, your pager goes off, there's a live event happening, high pressure scenario, you're responsible for incident management and working to triage and mitigate that customer impact. So what my team does is my team works on solutions to try and avoid that kind of scenario. So My name's Elliot Nash. I lead a team that is responsible for infrastructure scaling in Prime Video. We get involved in customer demand forecasting. We do capacity planning, like how much compute do we need to support our peak events. And we also do scale testing, so we run peak event game days that simulate the customer demand, and we do that frequently, like once in every region every week. As Tulip mentioned, today I'm going to walk through a journey that we've been on to migrate the key components of our stack to a multi-region architecture. So first, just a little bit about Prime Video. So we offer, we're a global service, and we offer a pretty comprehensive entertainment experience to customers where customers can subscribe. It's a subscription-based service with SVOD content. We also have a rich collection of movies and TV series for customers to watch. We've got lots of live sport content, which I'm here to talk about today. We also have a marketplace where you can purchase and rent content as well. This is all available globally. And our footprint is fairly large. So as a result, topics like efficiency and performance optimization are core elements of our culture in the engineering group. So the thing about live sports is when we first got into it back in 2016, 2017, we decided early that we needed to change our definition of availability. So we'd been offering an SVOD service for a number of years. The viewership demand patterns were very highly predictable, and they didn't really fluctuate that much. But once we got into live sports, we saw that we had these appointment viewing use cases. Everyone would come and join in that condensed period at the beginning of the match. Everyone would follow a very similar journey to get to the content and to hit play. And that was resulting in very sharp spikes of traffic, but also start forecasting problems where it's very hard to predict sometimes how many people would come and watch. So we sat down with AWS and we said, hey, we sort of explained that this availability we wanted to put in place for Prime Video and really raise the bar on availability, and we needed the service just to work. We said, we want the service to work on Prime Video's worst day. We even want it to work on AWS's worst day. And so we sat down with Dave Brown, who at the time was the VP of Compute and Networking, and we walked through these 3 layers of flexibility that I've got up on the board here. So the first layer is instance type flexibility. So by designing our systems to run on a diverse set of non-homogeneous instance types, we're able to significantly increase the available capacity pool. Now this approach helps reduce the risk of any capacity constraints like insufficient capacity exceptions or things like that. And it really takes advantage of AWS's built-in fault tolerance at the instance type level. The second layer of flexibility is AZ flexibility. So by leveraging multiple AZs within a region, it gives us built-in fault tolerance and isolation so that if one AZ experiences an issue, we're able to seamlessly fail over between AZs. This is kind of like the strategy of just not putting all your eggs in one basket, and it distributes the risk. So the final layer of flexibility that I'm here to talk about today is multi-region flexibility. This is really the crown jewel of our flexibility strategy. And so by extending our architecture across multiple AWS regions, we're able to create a robust, globally distributed system that can handle regional outages as well. It also enables us to optimize for things like latency by optimizing where we send customer requests based on their geographic location. So this has been a journey for us over many years. Back in 2017, when we first launched Thursday Night Football, it was co-exclusive at the time. We had the opportunity to build a live signal ingestion stack from scratch. So we were able to build that from the ground up to support multi-region. Around about 2021, 22, we introduced a multi-region live playback stack. So, and then this year, for the first time, we launched our storefront experience, which is kind of the key journey to get into playback in a multi-region scenario. And I'll walk through these 3 use cases too. So this is our high-level architecture at Prime Video. We've got a pretty large distributed technology stack with several hundreds of services underlying the boxes you see here. But kind of given the nature of streaming, we operate a large portion inside this, the boxes here on AWS, big portion of our stack that we directly own and operate. But we also rely on other partners such as ISPs, mobile operators, production houses, and device manufacturers to ensure that we have a seamless experience end to end. So just starting with the bottom rectangle here, this represents our live signal delivery stack. So this is where we take the produced content from the production source. And in the case of TNF, that is actually a production studio in a semi-truck outside the stadium. And we ingest that produced signal and we bring it into our elemental stack. And what we do is we encode it, we compress it, and we package it for distribution out through the CDNs. As I said, this part of the stack was built from the ground up to support multi-region. The middle box here is our playback stack. So this is the stack that contains all the services that help initiate playback, and it helps check customer entitlements to the content, and it initiates the video player to start the live stream. And the top layer here is our what we call our application storefront. So this is the area of the stack that supports the device front ends and the storefront back ends. So this part of the stack really serves the content discovery experience from app start through homepage load, detail page load to get you to the play button. The playback and the storefront stack were both originally single region stacks. So every given customer was pinned to a single region. Their data was segmented to those regions, and we could only serve that customer's request from that given region. And we supported about 240 countries and territories around the world. So I'm going to start with the signal delivery stack and go a little deeper. So one of the advantages of streaming is that we're able to deliver sort of pristine quality, picture quality and sound quality all the way to the home. So we produce the TNF games in 1080p HDR end to end, like from the camera lens all the way through to what the customers will see in HDR, and all the games are produced in Dolby surround sound. This is one of those trucks that I mentioned. We've got a traveling production studio that consists of 8 mobile trucks like this one. As you can see, it's a pretty big deal. The production units are fully redundant in every facet. So this is from like the routing core to the cameras to the trucks themselves to the thousands of feet of cabling that's laid out throughout the stadium. This is a picture from inside one of those trucks. So to handle this level of scale, we operate various production hubs, and we use them to monitor thousands of devices across all feeds in real time, and it helps us to ensure high quality regardless of the device the user is watching on. So this here is our signal ingestion architecture. Here is where we're monitoring the health of the signal and the feeds, and we're able to automatically failover between AWS regions here. These are our elemental region, AWS elemental regions. We're able to fail over between these regions if required. We leverage, one important point is that we leverage all of them in active mode, so there's always traffic going through all of them. We leverage elemental media services for signal processing and encoding. These services provide real-time encoding, transcoding, and packaging capabilities required for the live event. And we deploy our elemental stacks to multiple origin regions, and they process the signal in active mode. This approach helps us to ensure low latency, access to the live stream for viewers in different geographic locations. And then we deliver that live stream out through the CDNs. The orange box that I've got highlighted here represents what we call our edge reception and routing layer. Now this is a key sort of component that we've consistently rolled out for all of our multi-region use cases. In this case, It's an edge service that basically provides a layer of abstraction for the routing and failover decisions that happen between our elemental stacks. It lets us keep the routing complexity outside of the encoding pipeline, keeping the encoding pipeline isolated and as simple as possible within a given region. So this multi-region architecture here helped us improve our overall availability for our signal ingestion and delivery stack, and reduce latency and help improve the customer experience. So let's move on to the playback stack. So the use case here is we've got millions of customers coming to watch the TNF football, and they're all coming in and clicking play at the same time. Some of the requirements we set out with here were, again, we wanted this to operate in active-active mode. We didn't want any call paths that could go cold or stale that we're not frequently exercising. We obviously wanted to support regional failover, given our availability requirement that I described at the beginning. We knew that we needed some sort of edge routing layer. And so we thought this was, really the cornerstone of our multi-region strategy. And then finally, we knew we had to globalize to achieve this. As I mentioned, all of our customer cohorts were segmented into different regional stacks. And so that globalization would require changes to our service code base as well as our data layer. So here's just a quick use case of a call path that is coming in and then being sent across region through our routing layer. So the viewer clicks the play button and they could be served out of any one of our regions here. And the edge routing layer helps ensure that they connect to the best available node, while our data replication system is handling consistency in terms of the experience customers are provided. Okay, so the routing layer here is essentially acting as a request router. It's storing a configuration, and all regional instances of that routing layer are connected via VPC peering mesh. We implement routing rules, and they specify things like the customer's source country, the destination region, the traffic route percentage, and what it does is it effectively in real time is making routing decisions. The other thing it offers is it provides a customer with a consistent routing guarantee in the use cases where we need it. And so what that means is we're able to offer region routing stickiness to customer requests in the case where we want to handle read after write use cases in the same region. It can help us work around some of the constraints of CAP theorem. Okay, so that was our playback stack. Some of the big takeaways or benefits that we delivered here was, obviously we enhanced our resilience posture. We're able to handle multiple region failovers for our playback use case. We're able to deliver lower latency and higher availability and seamless failover. Okay, moving on to the final area of our stack, which is the area we launched this year. So our application storefront, very similar to playback in the work that we had to do. We needed to globalize our app start, homepage load, and detail page load use cases. And we basically we leveraged the same routing layer that I just described before for playback as well. So to globalize our services, we had to go and make changes in our code base to basically refactor our services to be region agnostic and make sure that they can run identically across different regions. We had to look at our data layer, and we had to make sure that our customer experience was consistent across different regions, no matter where the customer connects to. So we enabled shadow testing to do this, and we were doing API response diffs between different regions. And we also did scale testing in parallel to this so that we could simulate the region failover scenario as well. And obviously a phased launch plan so that we were able to simulate dialing it up and just see what the traffic patterns looked like as we gradually sort of shifted into this mode. Okay, so let's dive a little bit into one use case that we've got, which is our bookmarking use case. It's an interesting use case because it involves both read and write traffic. And what bookmarking is as you're watching a piece of content, the bookmarking service will take rights for where you're up to in the stream, basically, periodically. It sounds pretty simple, but for this use case, and especially with multi-region at this scale, it's pretty complicated. We wanted to ensure consistency. We needed to enable replication, so we've used DynamoDB global tables. And in this use case, we also enabled multi-master replication, so that the writes could happen in any region, and we would have an eventually consistent system. Yeah, so, and I mean, in addition to that, we also enabled, we had to migrate the data set, and for bookmarking, they had a combined data set of about 80 terabytes, and so we had to do a whole bunch of background work to globalize that data set and enable it in the globally distributed global table. All right, so there you have it. We've got slightly different approaches in every area of our stack that have basically produced a globally distributed multi-region architecture for all of the key critical core customer journeys that we've got in Prime Video to support the Thursday night football. This has helped us achieve global reliability and low latency, streaming for customers, and to provide the business with a durable, flexible architecture. So this year we used it for the first time on our storefront, and we actually served 50% of our customer requests. We do this every week now, every Thursday. 50% of our customers are going to multiple regions, and we've enabled millions of customers to have a smooth streaming experience despite some rapid surges in demand. Key takeaways from this journey have been, one, making sure that we deployed this architecture in a way that was always on, active, as I said, ensuring that we don't have any call paths that are not exercised. Two is automation, so as we're delivering the project, ensuring that the key operational tasks are automated at the same time, especially for things like that routing layer and how we actually tune the configuration. So there was a lot of automation that had to be built there. Testing, making sure that we're scale testing the different region scenarios in addition to testing the failover scenarios, because it can essentially result in a thundering herd event if you need to fail over at any point in time. And then finally, just iterating and learning on the multi-region strategy has been kind of like a continuous improvement project for us, and I think we're still just sort of getting started. So with that, I'm going to hand it over to Ralph, and he's going to walk us through our elastic scaling journey.
Thanks, Elliot. Hey everyone, I'm very excited to be here today to take you through our elasticity journey. Scaling elasticity is crucial for Prime Video, as it enables us to optimize our infrastructure resources and deliver a seamless streaming experience at high quality to millions of customers around the world. My name is Ralph Shaker. I'm a product manager in Prime Video. I work alongside Elliot on a central team, and we manage a portfolio of internal tools and products that hundreds of distributed engineering teams across our organization use for scaling and efficiency every day. So today, I'll walk you through some of the unique challenges that we faced in Prime Video when it came for live sports scaling, and then the opportunity we went after for efficiency. So, before we jump right in, a quick trivia question for all you sports fans out there. I saw a lot of you raise your hands. In 2024, does anyone know what was the peak audience for the Cowboys-Giants Thursday night football game on Prime Video? Go ahead. So, A is the right answer. Close. So, what does that mean? 18 million is a huge number. What that means is it just has to work. We have 18 million of customers at home streaming that we cannot disappoint. As you can see from the chart here on the screen, you could probably guess where is that 18 million? Right around there. Everything you see on the left-hand side of that chart represents our traditional video-on-demand business prior to the start of the Thursday night football season. And on the right-hand side of that chart, you can see each of those spikes represents a Thursday night football game with a game running each week. So pretty drastic difference in terms of just the sheer scale on a day we have a live event like Thursday night football versus a day where we have our steady state or baseline traffic. So what is Prime Video's role in all of this? it comes with a very big responsibility for Prime Video, AWS, and Amazon, right? This comes with a very large brand impact. And we must hold a very high bar to protect our availability, but we also have to do so in a cost-responsible manner. So it truly becomes a balancing act so that we can scale for these live events safely, but also efficiently, so that we could delight millions of customers who are our biggest sports fans across the country. All right, so let's start with some of the key challenges that we faced in Prime Video when it came for scaling for peak NFL. So one, as we talked about, is the overall scale. Internally, we call it the peak to mean ratio. And in that chart, you could see it's orders of magnitude difference the days we have the NFL Thursday Night Football streaming versus days that we don't. So that's one of the very unique things about Prime Video is the variability that we see day over day, week over week. And understanding these traffic patterns are key for us to understand how to scale for these types of events. Not to mention, these peak moments last just a few minutes, but are impacting our costs. And if, for some of you that know how the NFL season runs, you know, we have the regular season starting in September, running all the way through December, with the playoffs in January. So when you take a 5 to 6 month season and you scale up for that, which is in this case represented by the red line in the chart, it comes with significant cost implications, especially for an organization the size of Prime Video. So the second challenge here is spiky traffic patterns. So when it comes to live sports, it's very unpredictable. And the chart that you see here on the screen is a minute-by-minute plot that shows you what the curve looks like for a Thursday night football game. You could see at the steepest point is when the game kicks off, and then again at the halftime, when customers leave and then come back as the game starts over. And here's another example of a different metric, but it's looking at the number of page loads or page impressions. The tall spike at the very end that you see there is when the stream ends, and then you have millions of customers all transitioned onto the detail page for Thursday Night Football. And it's these spikes that we have to worry about, scale for, and ultimately consider when it comes to costs. So what this creates is, when we look at how could we auto-scale for this, relying solely on a simple auto-scaling or dynamic auto-scaling policy may not be sufficient because of how rapid these spikes are. You might look at this and say, we can't rely solely on a dynamic auto-scaling policy because this is a must-not-fail event, and we need to ensure that the capacity is there ahead of the event, it's scaled, it's tested. So the third challenge is the coordination effort. So as Elliot mentioned in his talk, Prime Video is a massive organization. It's made up of hundreds of distributed service teams. And ensuring each one of these teams is scaled by getting the signal from AWS and getting the capacity, provisioning that capacity, testing that capacity. These are very manual steps that teams have to go through today to ultimately say, yes, we're ready to go ahead of each weekly Thursday night football game. So it's a very expensive coordination effort with long lead times. So the combination of the long lead times, high effort, and the manual steps that are required has led Prime Video to really hold on to capacity a lot longer than is required. And that's what's represented here in the red line. It's the capacity that we procure, we hold throughout the season before we can release. All right, so next let's talk about some of the opportunities. So same chart that you see here, the white boxes are what we've defined as scaling waste. So you could think of this as the distance between the blue line, which is the demand or the traffic that we see, and the red line is the capacity that we hold. And that gap between these two lines is really the opportunity that we need to go after and minimize. Now, if you take that red line, and let's say you could transform it to something like this, you eliminate a lot of that waste, right? So one, we're reducing the number of days at peak scale so that all that capacity that you need for the 3-hour Thursday night football game is now only held for when you need it, and then you release it when it's no longer needed. And in turn, you'll reduce the infrastructure cost that you spend and the engineering effort for scaling up and down each week. So when you eliminate a lot of this engineering effort, it becomes a true hands-off the wheel scaling for engineers who have to deal with this on a day-to-day basis. Cool. So with that opportunity in mind, This year in Prime Video, we took a goal to build a product to go after this opportunity. How could we build something that automates the signal end to end and automate the auto-scaling? So this is a similar diagram that Elliot had up on his screen. One of the key things that we wanted to make sure we had when we built this product was how can we build it in a way that it's product agnostic? So whether you're running on vanilla EC2, ECS, Fargate, we want this to just work, because that's how we provide that leverage to the rest of the organization and become a true force multiplier. So next, I'll walk you through the high-level architecture of this product that we built this year. There are 3 primary components. There's the central forecasting system that we have. There's the main central hub that surfaces that signal. And then lastly, I'll talk about the transformation library, which is the component that we've had embedded within each of the service teams that have onboarded with this solution. So starting out with this forecasting system, think of this as really knowledge of the whole Prime Video universe. It knows what are all the upcoming events, the dates, the times, the forecasts, all the critical inputs that are needed to inform our capacity strategy. And I'll give you a quick overview of how does forecasting work in Prime Video. So this is a chart similar to the one that you saw earlier. It's showing you a year-over-year trend on how did our traffic, in terms of peak concurrency, grow from 2023 through 2024 TNF. We utilize a combination of different machine learning techniques, and we couple that with specific business knowledge for things like Thursday Night Football, right? That's who are the teams playing, who are the players, what are the standings, the records of these teams. These are intimate business details that we need to know to enhance the way we forecast and get more precise when it comes to forecasting. And you might ask, why is this important? Well, it entirely impacts our capacity planning. Some of you might know, but forecasting is a very challenging space. You can never be right. You're always guaranteed to be wrong, and it's how wrong and how you can minimize that. So on one hand, if you under-forecast, it poses an availability risk because you have insufficient capacity. And on the other hand, if you over-forecast, it leads to over-provisioning of capacity that's underutilized and not efficiently used. And then lastly, there's an element of trust. We have partners in AWS. We have our internal engineers, our builder community, and then external providers like ISPs, CDNs that all rely on these forecasts to go and build capacity, ensuring that Prime Video has this for our biggest events like NFL and other sports. All right, so moving on to the second and main component of the solution that we built. This is the central hub or gateway that we built. And think of this as the brains of the whole operation. It's responsible for routing all the requests that come into this component from the forecasting engine and ultimately surfaces that for the transformation library that we embed within each team that has onboarded to this solution. And this third component is that transformation library. So really, this is the component that lives within each of the Prime Video service teams that onboard to this solution. And it does 2 things. Through CDK constructs or templatized code, one, it deploys an agent, which is an AWS Lambda. And this Lambda is responsible for triggering the scale in and the scale out operations that are needed for auto scaling. Secondly, we're providing an app config file to each team. And in this config file, it allows any service owner to customize how do we translate one unit of demand into the underlying resources needed for auto scaling. So whether you're using EC2, that would be in instances or Fargate tasks. If you're using DynamoDB, it would be read or write capacity units. When you get a unit of demand, let's say it's in requests or transactions, we provide that flexibility to teams that might know better in terms of how do I think of one unit of demand and how many resources do I need to support that demand. So here's just a snapshot of what that looks like. So this is from the app config where the resource itself is defined that you want to auto scale. And in rows 9 and 10, this is where the translation function exists. In this case, TPS is what we use internally in Prime Video. It stands for transactions per second. And then the 0.001 is the multiplier that says, for every transaction, here's how many EC2 instances I need. And in this case, this multiplier is derived by performance testing on single one-box hosts to calculate what is the optimal throughput. Right. And then here, this is it in action. So this is a snapshot from a CloudWatch metrics dashboard that actually shows the desired count of instances scaling out from 4 instances to 10 instances. So this is the first time we actually found success in this product that we built this year. It was the first early results that we saw that this worked end to end and was automated. Right, so up until now, we talked a lot about scheduled auto-scaling and proactively signaling and pre-scaling capacity. So whenever you have predictive schedules like Thursday Night Football, which you know is every Thursday at the same time, we have to pre-scale that capacity. So we leverage scheduled auto-scaling. However, we also recommend using dynamic or reactive auto-scaling. We don't recommend one, we actually recommend using them both in conjunction as complementary services. The benefits of dynamic auto-scaling are real-time, immediate responsiveness to traffic. Going back to the forecasting example, if we have a situation where we have a surprise appearance from a celebrity, let's say Taylor Swift, or a very popular matchup, let's say the Cowboys, that exceeds our forecasts, we need to be able to react quickly. And this is where dynamic auto-scaling comes in as a guardrail that allows us to top up any shortfalls in capacity that we might otherwise not have. All right, let's talk next about some of the success metrics and the impact that we saw this year. Again, what we went after this year was just a pilot. We've selected a few service teams across Prime Video to prove out that this could actually work. And we identified 3 core KPIs that we wanted to move the needle on. First, we need to reduce the number of days at peak scale. We don't want to hold on to capacity, for 7 days of the week when the game runs for 3 hours on 1 day of the week. So in this snapshot, you could see for one of our services, it's representing the number of running ECS task counts. So a lot of step changes happening here. This first one that you see is the service scaling out ahead of the Thursday Night Football game. And then immediately following the game, it scales in the capacity. And then ahead of the next week when we have a simulated load test or a game day, it scales back out and then scales back in again following that. So what this results in is an improvement in CPU utilization because you have better utilization of your capacity, and then a reduction in cost. So with our pilot program, we saw a 30% reduction in infrastructure spend. And the key thing to highlight here is this was just for a pilot program. At the scale of Prime Video, we're talking millions and millions of dollars if we roll this out broadly to the rest of the organization and truly automate scaling for peak events and sports and introduce that elasticity. All right, next I'll talk about some of the lessons learned and best practices. So first, it's deeply understanding your traffic patterns on your application. For Prime Video, really before we had live sports, the question on did we need to pre-scale capacity? Likely not. But when you have events that change your traffic patterns or have rapid scale, understanding when do you need scheduled auto-scaling, when can you rely on dynamic auto-scaling. In our case, we used both. We took a hybrid approach because that's what worked best. Starting simple and then gradually increasing. Like I said, our goal this year was not to go after maximum cost savings. It was, let's prove out this capability, let's build confidence that it works, get the trust of our leadership, and then make sure that we can roll this out broadly and gain more adoption in the years to come. And then lastly, with any goal or with any program, identify what those KPIs are early on, obsess over those KPIs, continuously monitor them, and drive improvement. All right, lastly, I'll leave you with this. This is just an illustration that shows you the journey Prime Video went on into sports. So looking back at 2016, when we first started, we had just a handful of live events, and these range in the thousands in terms of audience. Then fast forward to where we are today in 2024, with Thursday Night Football, the Black Friday football game that just happened this past weekend, cricket, we could go on and on. I wish I had everything up on here. And then looking ahead to even 2025, the NBA, NASCAR are coming, and these are just other great candidates to have true auto-scaling and elasticity for. And the growth that we've seen thus far would not be possible without our ability to make sure we're scaling in a responsible way. Right, and with that, I will hand it over to Tula.
So I'll restart. So you heard the stories from Ralph and Elliot, and as in Prime Video, we say it just has to work, and that's what Prime Video did. And so to kind of recap, like what was the challenges and what was the solution? So the challenge was to deliver this stream to millions of fans out in the world, and it's just been increasing every year. And so there's like terabytes of data flowing over highly variable networks. And how did Prime Video do that? With multi-region and with auto-scaling. And so just to like see how many of you were paying attention, let's check the answer to this question. Like how many services, AWS services, does Prime Video use? Do you remember the answer to this question? Yep. Yeah, it's the same. It's 120 plus. It hasn't changed. But how did Prime Video do that? And Prime Video did that by adopting AWS's well-architected framework. So they started off while doing with reliability and went on to cost optimization. So most of you who are aware or who are using AWS are probably aware of the well-architected framework. And in the well-architected framework, we have 6 pillars: operational resilience, security, reliability, cost optimization, sustainability, and performance efficiency. And so for Prime Video, it was reliability, providing that 100% uptime and not impacting the video quality, while also looking at cost optimization, how to effectively and cost-effectively run their infrastructure on AWS. And so reliability was the goal, and resilience was the approach. So reliability determines how dependable the system is, and resilience is not to avoid failure. It is the ability of the system to return to a fully functional state as quickly as possible. Resilient systems have greater reliability. So if I had to recap, what are the design principles around reliability? And that's what Prime Video did as well, to adopt these design principles. It's automatic recovery from failure. It's to test beyond destruction, to make sure recovery procedures are automatic and successful. And so if a region fails, or an AZ fails, or your application fails, you need to be able to switch to an alternate region, or AZ, or application, or make that system work. And that's what Prime Video did as well. They had an active multi-region strategy. And then testing recovery procedures, very important. If you're trying to switch from a primary to a secondary region, what if it doesn't work? But you need to be able to test those before you kind of do that. And that's where it becomes really important. Then obviously scaling. And as those demands increase for Prime Video, they scaled. They scaled horizontally to increase aggregate workload availability. And that's what we do when we talk about reliability. We want to be able to scale as much as possible when the demand and the peak increases. Then stop guessing capacity. So we want to be able to guess how much we need. And if we got that wrong, there would be long provisioning time. And it takes time to provision EC2 instances or EKS or any of those services. So you should be able to stop guessing those capacity. And for Prime Video, year by year, as they have streamed NFL, they kind of have an idea of how much the capacity they need, how many fans are going to watch, and so they're able to get to the point where stop guessing capacity and able to scale up to those demands. And then lastly, managing everything to automation. If you're trying to do it manually, it can introduce errors. We are humans. We make errors. So we want to be avoided as much as possible. You can leverage CI/CD pipelines on AWS to be able to deploy those changes in an automated fashion. That brings us to some multi-region best practices. And so every data replication that happens, it happens across long physical distance. And if it happens across long physical distance, across regions, across AZs, it's hard. And so you want to be able to understand consistency and replication options along with benefits and trades-off, and that helps you choose the technology that's best fit for your workload. And if one of your design goals is to increase availability and performance of your application, then you should take a serious look at asynchronous application as well, where you can asynchronous do replication for your tables, for your S3, and be able to have the same data across all your regions and AZs. And also, like, allowing active multi-region writing has its challenges. But having idempotent transactions and a handle on conflicts will help to eliminate those unwanted behaviors. And then lastly, when you're having all these applications running across multiple regions and like multiple ACs, you want to have this differential observability. You want to be able to observe your logs, your traces, and everything. And that should basically give you a holistic understanding of the health of the system. Because when you're trying to switch from a primary to a secondary region, and if it's not available and the health check fails, you don't want to do that. And so I'll cover like 4 fundamentals. First, understanding the requirements. So 70 to 80% of our resilience conversations we have with our customers starts with the discovery of the RTO, RPO requirements. What's the recovery point objective? What's the recovery time objective? For Prime Video, they want it to be at it as low as possible. And so to understand how many outages have happened in the past couple of years, what was the impact on the business, and trying to answer if going multi-region helps to improve the ROI of the business. So it's very crucial to capture that information as the first step before we proceed to the multi-region architecture. Then comes data consistency, and that's where the CAP theorem comes. So the CAP theorem provides guidance to design a distributed system where 2 out of the 3 characteristics need to be satisfied. So for primary, one of the primary important things was data replication for real-time synchronization of user sessions. And Elliot kind of elaborated that in his session part as well. And so when we talk consistency, it's when 2 requests are made from 2 different sources against 2 different nodes. They always return the same data. And then availability is defining the system is available for reads and writes. And then we have partition tolerance, which is when the system continues to operate despite failures, such as drop partitions or slow network connections. And you want to be able to define 2 out of the 3. So let's say if you choose consistency and partition tolerance, you get lower performance because we need to validate the data for the consistency and wait for the system to become available. And if you choose availability and partition tolerance, you get eventual consistency, so better performance and non-zero data loss for in-flight transactions. So you get to choose 2 out of the 3 and kind of design your system with that. And that brings us to understanding dependencies. So one of the key things, like if you have third-party applications that you're calling, you need to be able to identify what's the latency requirement for your application and see how the internal and external dependencies influence the decision. So assume a scenario where your primary region depends on a third-party endpoint, which is temporarily unavailable. And so you want to be able to switch to the different region. And now the different region has to make the same API request, but it's still going to fail. And so what we need to do is it doesn't fail. And so we also need to check is that like the latency is the same. So A, we want to do a graceful failure, and B, we want to have the same latency that was there previously so that your latency requirements are not impacted. So that kind of brings us to the 4th fundamental of operational readiness. So when you have your primary region and you're running your application, and you need to switch from primary to secondary because your primary is unhealthy or something happens, it's unavailable. And while you're trying to switch, let's say the app code has the latest code and software, but it doesn't have the latest changes and it's not working as desired. And so when you switch to your secondary region, it's going to fail. So you want to be able to make those informed decisions before you switch to your secondary region. And so for that reason, you need to be aware of the account limits, of the cross-region health checks. So before you switch from primary to your secondary, if there's a throttling limit or your applications that are running, your EC2s are unhealthy, don't switch. So make those informed decisions around that before you try to do it. And obviously, as we talked about, make those switchovers, all those recovery procedures as automated as possible, and also test them before you do it. So that brings us to key takeaways. And again, as in Prime Video, we want to be able to make everything work, make it work. And so the system has to be ready for those spikes. And so for Prime Video, what they did is the things that they achieved was operational resilience. so supporting growth for millions of users on TNF days. So they started off with resilience, like the reliability pillar, and they kind of slowly moved towards optimization. Secondly, they were able to dynamically scale. So their peak to mean ratio was highly variable, like 5 to 10, sometimes 5x, sometimes 10x, and sometimes even like more than that. And so the baseline, this was the baseline to their NFL days. So on Thursday night on football, like they would see a peak out there. And then optimizing cost. So they saw a 20% reduction in cost in operations. And also, like Ralph talked about, the 30% reduction on their pilot. They saw a lot of optimized cost as well. So as you're moving from left to right, they started to see those optimizations. And then lastly, carbon savings. They saw a 43% reduction in carbon footprint, reducing number of EC2 instances, as well as adopting Graviton. So what the point of is, like, as you're trying to adopt resiliency or cost optimization or trying to learn what Prime Video did, the primary thing is to be focused on one thing, and for Prime Video was reliability, and then kind of move on to the cost optimization. So like focus on one thing and then be moving on to the other reliability pillars and be able to do what you want. And lastly, I'll end with this quote from our CTO, Dr. Werner Vogels: "Everything fails all the time." And so we need to build systems that embrace failure as a natural occurrence. And that's what Prime Video did. They knew it might fail, regions might fail, applications might fail, ACs might fail, or something else might fail as well. What they did is able to apply those strategies, like multi-region, auto-scaling, and be able to scale and so that their users are not impacted. And their users are able to watch Thursday Night Football every Friday, and even on Black Friday football that we had last week. And with that, I'll end the session. Thank you for attending the session. These are our information out there, our email IDs and LinkedIn. Feel free to add us, feel free to email us. And there's also a survey on the app that you can use to provide us feedback, how we can make it better. And we'll be out there on the site if you have any questions for us. So thank you. Thank you again.